Good morning, ladies and gentlemen. In many ways, the presentation I'm going to deliver this morning continues with the topic of security. This time we're going to be talking about the security of supply for a very important asset to Wyoming, which is coal. The title of my presentation is Sustaining the Presence of Coal in the Energy Mix through Wyoming Research, Technology and Infrastructure Investment. I've split the presentation down into 4 sections. I'm going to talk about the current state of coal supply and demand, some of the major challenges that's faced at the moment, just at a very high level. I'm then going to talk about the outlook and some of the real issues, I think, which will confront coal if we don't move now and deal with the future of coal from a research and technology perspective. I'm then going to talk about some of the limitations of the technology that we know today, set in the context of the market environment, and finally say something about what the University of Wyoming is doing in terms of looking at the future of coal. So this first slide is talking about the market challenges for coal. I think it's evident to all of us that coal is used primarily as a source of energy in electrical and power. And its value is constrained at the moment by the market rivalry that's happening, which is primary energy such as nuclear, gas and renewables, and obviously not so much as oil, because that's really in the transportation sector. And that if we look at this graph, and if we extended it out further, what we have in the situation at the moment where we're reducing market share in the USA for coal. So essentially, coal has many issues. It has regulatory pressures as well, and it also has the rivalry amongst its alternatives. And when I think about the regulatory environment, there are 2 major threats, all related to the CO2 regulations. In the short term is the EPA Clean Power Plan, which may become final this summer. And at the bottom there is a recent graph that's been published by the Department of Energy, I think about 4 days ago, which shows the impact on coal of the Clean Power Plan. You'll notice that both natural gas and coal are affected in terms of the expected retirements. But in the case of natural gas, there's also an expectation that because of technology and the economic situation, it may thrive. But in the case of coal, which is shown at black at the bottom there, it's all very negative. And these are the DOE's figures. Some work that we've done at the university says that, in fact, these figures for coal may even be conservative. In the long run, if we think about up to the year 2050, and we look at what's going on in the United Nations Climate Change Conference, which will be concluded in December of this year, what we see is that there's a strong lobby to reduce the CO2 emissions by up to 80%. That is incredibly challenging for a coal plant, particularly in terms of how we're configured today. So in the long run, things for sure are going to get worse. They're not going to get better if we just think about the markets for coal as we see it now. If we superimpose that further and we start looking at the market outlook for North America, what we see generally in the demand for energy is that energy consumption growth is generally going to slow down because of various energy efficiency considerations and other factors. And if we think about the impact on coal consumption, we see there that coal is just going to decline in terms of its presence in North America. It really, as it stands at the moment, it's very difficult to see a future. And if we just look at the power sector alone, of course, which is the primary use of coal, then we get this plot here. So we start to see a really significant depression up to 2035, where it's gone from a market share typically around 50% down to one of probably nearer 10%. And these figures are all taken from the BP Global Energy Outlook, which is published each year. I particularly like the BP Global Energy Outlook because it matches it to economic output. So it starts with GDP at the national level or at the international level and works back to supply, taking what I consider to be reasonable assumptions and not exact. I just like the framework it uses. If we look at the outlook on the global perspective, what we see is a slightly rosier picture for coal. We see the coal demand in China and India is significant and having a major impact on the total output at the global level. And if we start to think about, according to BP, in China and India, coal is projected to be 66% of the total coal demand in 2035. So increasingly, India and China is going to be the key market for coal from a power and electricity generation perspective. And if we look at the breakdown of the global primary energy outlook to power, it shows coal demand is largely supported by this Asian economic development. So it's a bit more rosier than in North America. But of course, one of the biggest challenges, particularly if you're in Wyoming, is you have a little logistical disadvantage of being able to get that into these new markets, particularly when you compare that to places like Australia, who also have abundant coal resources, and the logistics of getting that there is even cheaper. So that sort of gives us the context that we're working in today. But if we start thinking about new markets for coal and market opportunities, then we can start thinking about coal to get into new markets for manufacturing non-metals and chemicals. And this is essentially the area that the University of Wyoming are starting to investigate to some extent. Why is it attractive? Well, as you'll see later on, when I put one slide up, when we talk about refining and we talk about refining oil, we sometimes forget that the very first refineries were built on coal tar. They were not built on crude oil. So essentially oil pushed coal out of this market of manufacturing. And what we believe is an opportunity now for coal to get back into that market. Simply because it captures value beyond its BTU value. And it turns the CO2, which at the moment is emitted by power stations, into products. Or, of course, if we manage the carbon in the right way, we don't make it in the first place. So when we think about coal to chemicals plants now, they're starting to see them emerging in China, in Germany, and in India. And when we look at the demand for carbon-based materials now as a whole, we start to see this sort of outlook here. So we start to see significant inroads in carbon-based materials, and even in that green segmentation of the pillar plot, even in America, an emerging, a mature market, we're starting to see the demand for carbon products growing at 3.8% per year, which is greater than the projected GDP growth for the country. Of course, when we start looking at the Asia-Pacific areas, we're up to 13.8%, et cetera, et cetera. But the point is, we have an industry in North America which is growing, and the demand for carbon-based materials is rising. And this is due to lightweighting, particularly in automotive, where you're starting to see the CAFE standards are being affected not just by building better engines and fuels, but it's also by making lighter vehicles to create that. Also, we're starting to see substitution for metals. Metals are going up in price. So as we get more and more superior high-performance non-metallic materials, we're starting to see this penetration into these markets. And of course, we're starting to see superior functional performance of these carbon-based materials. And many of you have seen graphene, carbon fibers, and things like that, which are really have significant impacts on what we can do now with design and engineering. And there's also a growth in industrial and chemical solvents as well, which is also an interesting area. And all of these materials are and when we talk about solvents, are all materials that are based on carbon. So Okay. This gives you this is a tree, it came from the US Geological Survey, showing all of the possible materials that can be made from coal. In the past, coal was used to make many of these materials, but unfortunately got pushed out of the market due to the lack of technology investment or research, and additionally for things like it was regulated against. Particularly from the point of view of polluting contaminants like arsenic and sulfur and things like that was pushed out. So coal has a history of poor investment from a research and technology perspective. I think that's very important, and that needs to change if we're to create a sustainable and a positive future for coal. So this is showing a basic integrated diagram of a process showing how coal can be converted into many materials through the management of the carbon molecule itself. I won't go into it, but as I said earlier, the first oil refining process was invented to upgrade coal more than 150 years ago by Edward Drake. This is before Edward Drake touched off the boom with his discovery oil in Pennsylvania, and things moved to coal. So coal lost its market share in things like this. And these are some of the materials where coal can get into and has potential and has been used in the past. So I want to move to China. Earlier on, I talked about the importance of China in the presence of coal, and I want to say something about what China is doing now from a coal perspective. This is the diagram showing all of the coal-to-chemical projects that are either planned, approved, under construction there. They're all based upon the concepts of taking coal, breaking it up into its lowest form, its lowest molecular form, and then rebuilding that up into more complicated molecules. But one of the issues in China, when we start to see the use of water to do all of these things, then what we find is that water becomes a big challenge to this future. So this is a map showing the total installed capacity in China. And most of it is being built in aggressive water-scarce regions. And if we look at from the power perspective, it plans to put another 1.2 terawatts of power into China by 2030 together with, and this alone is all, let's say, located in these areas and regions of China where there's already significant water stress. So one of the biggest problems that we foresee is without upfront action on this water problem, then this future Chinese thermal generation capacity that's been approved or planned could easily be stranded. It's a really big issue for China. It's a problem for the world, but particularly in China, and this is the big hope for coal. I want to say something now about the technological aspects of coal conversion. Gasification is the common platform that's been used. Basically, we smash it up, we make synthetic liquids from it, and then we use these as building blocks to get higher. One of the biggest challenges with gasification, if we go back to $100 oil, then what we saw was gasification was starting to look attractive if we got technology breakthroughs. But at low price oil and low price primary energy, which has been cut by 50%, the economics of gasification look really very, very poor. And there either has to be very significant breakthroughs in gasification, or alternatively, we have to start thinking differently if we genuinely believe that this low energy price environment is here for years to stay. And that's certainly the view of many people. When we look at gasification, this is showing from GE, this is showing some the market drivers that are making things happen in the USA. Of course, we're fighting against the possibility of syngas against low-price natural gas. And so at low-price natural gas, it really is pushing gasification out of the market. In the EU, power demand is low. So gasification probably has more limited potential there. And China, of course, have already made significant sunk cost investment in gasification. So the likelihood is there is some robustness there. But in the long run, as you'll see in a minute, even China's changing its view. I could go on. So the low natural gas price challenges the economic viability of gasification, no matter which market you're in. that's for sure. The other alternative route is liquefaction, which is known. Liquefaction is an area that has increasing interest technologically because it doesn't go back to the basic molecule. It has the potential to actually break the coal down in ways where we can produce in a disciplined way both the gases that we require, the liquids we require. In this case, it's showing transportation fuels, and also in terms of the solid materials that we want. And if we start thinking about carbon rejection rather than hydrogen addition, I think this is going to be very critical if we start thinking about converting coal into these high-performance products that I mentioned. So we have to start thinking about looking at mild liquefaction, coking, pyrolysis, destructive distillation, and other methods. And it's not a very good slide, but this is just showing the nature of if you start thinking about managing the carbon rather than adding the hydrogen into the mix, then you're able to start to think about producing families of materials that are potentially very, very valuable, and we'll talk a little bit more about that in a minute. So, as I say, this carbon rejection approach, and historically, we've tended to add hydrogen when we think about refining and manufacture. Hydrogen is, coal has a very low concentration of hydrogen, as we'll show in a minute. And so one of the issues is where would the hydrogen come from? So thinking about rejecting carbon when we start thinking about manufacturing these high-performance materials, I think is going to be vital. Because if we manage it, we can turn it into product rather than emit it. So we have that advantage. And when we look at carbon rejection technologies, generally speaking, they have a much more lower water consuming intensity than hydrogen addition processes. And this graph at the bottom, which is taken from the IEA, shows typically for gasification and liquefaction, the sort of issues that we get in terms of water consumption and tons per coal of ton process, and also in terms of the CO2 emission from it. And that's what we're really trying to get around. If we are going to start thinking about coal as a manufacturing material, then we don't want the same impediments that we're starting to see in power, which is the water consumption issue I mentioned earlier, and the CO2 emissions problem. So in China, I said that China is already thinking about moving on from its current technology platforms like gasification. Very recently, they announced a very large program of research going on, thinking about the simultaneous production of these high-performance materials and energy at the same time. And this is conceptually where a lot of research is going on in China at the moment. We think we can do better than that, which we'll talk about in a minute. If you start thinking about managing coal in a more deliberate way, and particularly taking advantage of what we believe are the advantages of Powder River Basin coal in Wyoming. So let's move on and talk about Powder River Basin coal. This is the price of coal. Powder River Basin coal at a price per ton, so it's less than any other material, so it has a price advantage if we can do something with it that's significant. But it's also a better prospect for chemicals production due to its bituminous content. So if we think about Powder River Basin, it's classified as a subbituminous material, therefore its volatile and organic content is high. These are things that we can produce nice molecules, which we can start to make ring-type products from. And one of the big advantages of Powder River Basin coal is it's the lowest sulfur and naturally the cleanest coal in the United States. Has a high water content, so if we can extract that water and actually use it in the processes, then even in areas where the water availability is challenging, we could in fact think about this as almost a self-sustaining process by thinking about reusing the water that we take off. And one of the other advantages of Powder River Basin coal, it has very low concentration of trace elements such as mercury and arsenic when compared to eastern US coals. So it has this advantage that essentially it can produce much purer materials if we were to process it. So what are we thinking about when we think about PRB coal? Well, we're thinking about it in the same vein as how we might think about refining oil. When we think about a refinery, one of the attractive benefits of thinking about coal in a refinery context is that in refineries we make many, many products. And refineries would allow us to make the right products, to switch to different products dependent on the market supply and demand, so that you're not beholden so much in the market by the price of a particular product. You're beholden more by a range of products, so the business model would be more robust. Two areas that we believe that we need to work on from a research and technology perspective. We need to start thinking about the carbon conversion processes that we would need to do to be able to convert Powder River Basin coal and take advantage of its properties to make these high performance products. And the products shown there as coal chemical products that we believe are worth looking at. These families would be pitch. Think about pitch that we might put into asphalt. Think about pitch in the good old days when I was a boy, we used to have coal tar soap. And we used to wash ourselves with coal tar soap. So there's many opportunities for pitch, even in putting on the roofs of houses and things like that. Activated carbon, a very important growth product market, particularly in filtration. Carbon composites, I already mentioned about lightweighting. Aerogels, which have significant properties. These are materials used in thermal insulation and things like that. Graphene, of course, which is a very high performance form of pure graphite. And from the point of view of the product slate, petrochemicals, then we could start thinking about acetals, alcohols, aromatics, asphalt, carbon fibers, carboxylates, and needle coke as being the intermediates that this coal refinery might produce. But of course, to do that, we need to understand the properties of the products as well. So from a research and technology point of view, it's not just the making of these types of materials, it's also understanding how they compare to the sorts of materials that are already out there and come from other materials. So we're trying to always think about creating competitive advantage for coal by looking at new carbon engineered solutions and the processes together. So, as I said earlier, the management of carbon is going to be crucial. When we think about carbon, we have to be very, very conscious that the hydrogen-carbon ratio is low. It's 0.5, so it's going to restrict us to ring-type chemicals in particular. It may, of course, mean that if we think about this coal refinery and we think about maximizing the yield of valuable products from coal, then of course we would start thinking about minimizing the CO2 emission. But of course we may need to think about inputting the refinery with other materials like LPG or even natural gas. But the overall objective of what we're trying to strive for is full conversion of the coal itself. And if we do that, of course, we also minimize waste. So what does this mean if you're a coal refiner? What does this mean in terms of value? Well, these are some rough estimated figures we've put together that says if we take about a ton of coal, it contains about 21 gigajoules of energy. And if we assume full conversion, then a ton of coal can make typically 159 gallons of gasoline. And if we then relate everything to a typical 100,000 barrel a day refinery, which is a full conversion refinery that makes fuels and chemicals, then we start to see a refinery that manufactures about over 500,000 gigajoules of product, which is equivalent on a full conversion basis of about 28,000 tons of coal if we were to build something that was the equivalent of 100,000 barrels a day refinery. But a 100,000 barrel a day refinery is really only 70 to 80% efficient. So really we can add those figures up and we can add about another 20% of those figures in terms of likelihood of the tons of coal that would be consumed in a refinery of that size. So if you think about it as a 250,000 barrel a day refinery, I did some sums the other day, you're thinking about 3 major train loads of coal that would be departing Wyoming every day that would be consumed in the state. So it is significant, particularly if we could put that, a coal refinery eventually in Wyoming itself. So what are the aspirational goal outcomes that we have? Well, we're trying to develop a sustainable value stream of carbon-based projects that leverages the competitive advantage of the coal that's actually in the state. If we do that, we can penetrate new markets, which complements existing power and energy. So the potential for a new industrial base in Wyoming, either we could think about this separate from or adjacent to a coal mine or even a coal-fired generation plant, because we need to think about electricity and power as being a possible co-product if we're making these materials. And of course it provides export opportunity for made in Wyoming valuable chemical products to establish emerging and national and international markets. I mentioned earlier the economic growth in chemicals. So one of our primary objectives at this stage is to develop intellectual property in this area that will help us distinguish and advance the university's energy conversion and advanced technologies pillar that we have, which is one of our primary strategic goals. If we did this, we believe it would enhance the perception of coal utilization entirely. It would take people's thinking away from seeing this as an opportunity. After all, it's an abundant resource. It would be an opportunity to develop new consumer markets. But to do this, likelihood is we'll need to develop collaborations with industry and scholars elsewhere if we're to motivate this interest. One of the biggest interests, of course, is getting this to happen. And the next thing is, of course, it sustains a future for coal over and above where it's at the mercy of other materials in the power and electricity market. So what are our next steps? This is the last slide. Our 2-year plan, which we expect to get funded and start this year. The first thing we need to do is to understand the decomposition properties of Wyoming coal to leverage its competitive advantage. Surprisingly, when we look at the literature, there are many things looking at properties of coal, but when you start to look at how coal breaks down in a science and engineering manner, there's very, very little information. So the first thing we need to do is to build that database up to see how it decomposes and what we can actually realistically do with it. And one of the early things we started is to do a stoichiometric analysis which determines the slate of possible products that might be manufactured from Powder River Basin coal. This is basically matching molecules that are in the coal and atoms in the coal with atoms and coals at the end and doing a mass balance. So if we do this, we have to think about added water as would be minimal, reusing the PRB water content, which is high. We want minimum CO2 release, so we will focus on taking the carbon out before it gets to the CO2 phase and making these products. And waste and energy use optimization. One of the other advantages of Powder River Basin coal is it's quite exothermic or active. So if we can focus on exothermic processes rather than endothermic, which is putting energy in, then of course we're able to think about energy use optimization too. And once we've done that, the next objective is to do the techno-economic viability of a coal refinery to build a real proper business case for this. But one of the biggest challenges we foresee is what is the compelling business model for the state of Wyoming that will attract investors to want to make a coal refinery happen. We're in an industry at the moment, a coal industry that is in very highly stressed, some might argue in crisis. So where's the money going to happen? I mean, banks historically have been very reluctant to invest in anything to do with coal. So how this is going to happen, I think, is going to be, one of the cruxes that we're going to have to deal with once we have this information in terms of understanding what the business case might be. It's going to take a lot of effort. I just want to thank my colleagues in the School of Energy Resources, Carl Bauer, Kit Coddington, Rob Hurlis, and Mark Norton. Thank you for your attention, ladies and gentlemen.
Questions from the board? Let's give Richard a big hand first. Then we'll take questions.
I apologize if you mentioned this because I came in after you'd already started, but you hit on the business case and some of the additional things you have to do, but have y'all done a back of the napkin yet? We heard from Ed Hers earlier about some of the world oil prices and if oil coal to oil is one refinery option. Kind of what's the ballpark break-even point, that oil needs to be at for this to be economic?
It's a good question. I think from a ballpark point of view, I think it's sometimes very difficult to quite do that analysis because we're looking at different markets. We're looking at a coal refinery to produce products which coal cannot make, rather than what coal can make. So things like olefins and polymers and those sorts of solvents are very hydrogen rich. We don't want to focus on those, so we want to focus on these carbon-based materials where we believe the future holds. If I had to think about competing, I would be thinking more about gas-based petrochemicals as my competition base, because gas at the moment is used to make a lot of carbon-based materials. So I would see it more in that vein. From a competitive point of view, I think the advantage for coal is that we have a net benefit of around about $2 or $3 on a million standard cubic feet of gas, which I think is a better measure to use, particularly as I think ultimately you're trying to use coal to make fuels for motor vehicles, and we know that if we're trying to make coal into fuels of that type, then we have to break it down through gasification. There's very unlikely we would get much yield of fuel directly from decomposing coal. So I think the analogy with coal and oil is probably not a good one at this stage, based upon what we know today.
So then if I heard you right, you're thinking in the $2 to $3 per MCF, did I hear that right?
That's about what we believe it is at. For Powder River Basin coal, if we start to look at the more higher priced coal, then we couldn't probably make some of these products that we have in mind, particularly the carbon fiber materials and things like that. So really we're trying to take advantage of something that is a low price in the market by thinking about the bituminous content. I think it's an opportunity simply because of the way it's priced at the moment. But of course the price would go up, one assumes, if it became more valuable, yeah? So.
Other questions from the board? Question from the audience? So let's give Richard another hand. Thank you so much. Keep us up to date with your efforts, and we'll do the same, and hopefully we'll see each other soon.